Section 3 of Chapter 1 is about the properties of real numbers. So by the end of this lesson, you should be able to recognize the properties of equality and identity, and also the commutative and associative properties. So the expression 4k plus 8k and 12 are equivalent expressions. And the things that make them equivalent are that they represent the same number. If you were to add 4k and 8k, you would end up with 12k. The properties that we're going to study allow us to write equivalent expressions to simplify, solve, or help us understand a problem. So here are some of those properties of equality. And chances are you take all of these for granted, but we have to define them, and we have to know that they exist in order for us to do some of the math that we're going to do in this class. So the reflexive property means that any quantity is equal to itself. So A equals A. So for example, 5 equals 5, and 4 plus 7 equals 4 plus 7. The symmetric property says that if one quantity equals a second quantity, then the second quantity equals the first. So for any numbers A and B, if A equals B, then B equals A. And you have done this one before. If you've ever gotten something like 15 equals 5x, and you solve, and you have 3 equals x, chances are you wrote this as x equals 3. This symmetric property tells us that those two things are exactly the same. The transitive property is also an important one that says if one quantity equals a second quantity and the second quantity equals a third quantity, then the first quantity equals the third. So let's say you know A equals B and that B equals C. You can skip this whole B part and just say that A and C are equal. So it gives you an example with numbers over here. 6 plus 9 equals 3 plus 12, and 3 plus 12 equals 15. Then you know 6 plus 9 also has to equal 15. And we use the substitution property a lot, and it says a quantity may be substituted for its equal in any expression. So if I tell you that n equals 11, and I give you 4n, you can plug that 11 in, and it's the same exact thing as 4 times 11. The sum, remember that means addition, of any number and 0 is equal to that number. Absolutely any number. 7 plus 0 equals 7, not 0. 8 plus 0 equals 8. 432 plus 0 equals 432. Absolutely any number. And because of that, 0 is called the additive identity. And that's because you add 0 and it keeps the number's identity. It keeps the number exactly the same. So the additive identity is 0. The additive inverse is what gets the identity. So in that case, the additive inverse is just the opposite number. So if I have a number like 7, and I want to add something to it and make it equal the identity, it would have to be -7. I would have to take away all 7 of those things. So inverse and identity, I know they both start with the same letter, but keep those straight. Identity keeps the number the same, it keeps its identity, and the inverse undoes the number or gives you the identity. And we also have these properties with multiplication. So for both of those it was addition, now here's the multiplication. So the solution of this equation right here has to be 1. Because I want to multiply something by 4 and still give me 4. So 1 is the multiplicative identity. So additive identity equals 0, multiplicative identity equals 1. And remember, it's what you would do to a number to keep it the same. And just like with addition, we also have an inverse. Remember, the additive inverse is the number's opposite, like 3 and -3. The multiplicative inverse, remember we got to multiply something together and have it give us 1, so that's the reciprocal. So think like 3 and 1/3. If you multiply those together, you end up with 1. Or here, if you add these together, you end up with 0. And then there's another awesome thing about multiplication is anytime you multiply any number by 0, you get 0 out. And that's called the multiplicative property of 0. So here's all of those in a nice pretty table. So the multiplicative identity is 1. The multiplicative inverse is the reciprocal, so it has them flipped around. And the multiplicative property of 0 says that if you multiply 0 by any number, you get 0. So we need to evaluate this and then name each property that we use. So let's set up a nice little table. And we're going to start with our expression. And then we got to follow GEMDIS. So the first thing I'm going to do is grouping symbols. So 4 minus 3 is 1. So think back to all of our properties that we used here. And in this case, all we did was substitute. I know that 4 minus 3 equals 1, and I replaced it. So substitution. So next step, next thing I'm going to do, this grouping symbol is only serving the purpose of multiplying now. So I'm going to multiply. 7 times 1 is just 7. I'm going to rewrite everything else exactly the same because we're writing down the steps. And the reason I know this is because of the multiplicative identity. I know that any number times 1 is going to give me that exact same number. So now I still have more multiplication down here, and 5 times 1/5 is just 1, and that's because of the multiplicative inverse. And that says a number times its reciprocal is 1. And then we got to do some simplifying here, so we're going to do something and substitute. 7 minus 1 is 6. And then the last one, 6 plus 1 is 7, and that's also substitution. So now here's the other two properties you got to know, the commutative and associative properties. The order in which you add or multiply numbers does not change their sum or product, and this only works for addition with addition and multiplication with multiplication. If you are multiplying and adding, you can't switch them around. If you are subtracting or dividing, you definitely can't switch them around. So this says that 4 plus 8 is exactly the same thing as 8 plus 4. It does not matter. Even if you have more numbers in there, 3 plus 1 plus 2, it doesn't matter if you add 2 plus 1 plus 3. You will still get 6, no matter what. The associative property says that the way you group 3 or more numbers when adding or multiplying them does not change. So if I put parentheses around these guys when they're all adding, I get exactly the same thing as if I put parentheses around those two. Remember, parentheses tell us what to do first. So we'd have 8 plus 7, where here we would have 3 plus 12, and either way you get 15. So the awesome thing that we can do with this is we can rearrange numbers to make them easier on ourselves when we multiply stuff together. Like if I was doing a problem like this without a calculator, I would multiply 6 and 9 together first and then multiply that by 2 rather than getting 12 and trying to multiply that by 9. But either way, it's going to give us exactly the same answer. So let's do a problem like that. Evaluate 5 times 7 times 4 times 2 using the properties of numbers and then name each property that we used. So when I look at this, I see some nice, pretty numbers, and then I see some not pretty numbers. So the first thing I look at is 5 and 2 make 10. 10 is insanely easy to multiply by anything, so I'm going to rearrange this. I'm going to make 5 times 7 times 4 times 2 equal to 5 times 2 times 7 times 4. And I switch the order here, so that's commutative. And because it's multiplication, it's a commutative property of multiplication. And then I'm going to group these together. I'm going to make it 5 times 2, and then multiply that by 7 times 4. Again, because I want a 10 here, and that's going to make it really easy. So this is the associative of multiplication. 5 times 2 gives me 10. I know 4 times 7 gives me 28. So that's just substitution. And then 10 times 28 gives me 280. So you could have done 5 times 2, gotten 10, multiplied that by 7, gotten 70, and then multiplied that by 4, and you still would have ended up with the same answer. But for this, if we group them together, it's two nice, easy numbers that we know, and then we just have to multiply one thing at the end. So same thing when I look at this. The first thing I'm going to do is I'm going to rearrange this. I see this 3 in the denominator, and know this 3 in the numerator is going to help me out. So I'm going to move them around. 5/3 times 3 times 25 times 2. And remember, that is commutative. And then I'm going to group them together. I'm going to do 5/3 times 3, and then I'm going to multiply that by 25 times 2. I'm grouping up numbers that are nice and easy to multiply. So 5/3 times 3, remember we can turn this into a fraction, you end up with 15/3, which is just 5. And 25 times 2 is a nice easy 50. And then I can do 50 times 5 and end up with 250. And that's also substitution. So I want you to evaluate the expressions and then name the property that you used. The first two should be properties of equality and identity. Commutative and associative should be the last two, numbers 5 and 8. Make sure you write down any questions you have, and we can go over them in class. Enjoy your night.